Ever feel like you're just drowning in information when it comes to infectious diseases?
Oh, yeah.
I mean, bacteria, viruses,
Yeah.
fungi, parasites, it's a lot. But don't worry.
Hmm.
Today, we're throwing you a lifeline.
Yeah.
We're diving deep into carbapenems,
Those heavy hitters.
the antibiotic superhero.
Absolutely.
Think of this as your Bugs and Beyond 101 guide to carbapenems.
We're going to break it down so you walk away feeling like you aced the first exam in carbapenemology.
Oh, I love that. But before we get started, I think it's important to just take a moment and appreciate our bodies.
Yeah.
I mean, it's pretty incredible how our immune systems are constantly battling all these invaders.
Absolutely.
Even when we don't even realize it.
He really is a marvel of nature.
Yeah. And speaking of marvels, carbapenems can be real game changers when our immune systems need a little extra help.
Absolutely.
And their discovery is a testament to human ingenuity.
Yeah.
All started back in 1976 with this naturally occurring compound called theanomycin.
Yes.
Theanomycin. It sounds almost mythical.
It does?
Was it discovered in some hidden jungle or something?
Not quite a jungle.
Okay.
But close. It was actually produced by a soil bacterium called Streptomyces cattleya.
Interesting.
Theanomycin showed incredible promise. You know, it could fight off a wide range of bacteria, even those sneaky ones that produced enzymes to break down other antibiotics.
So like the ultimate warrior.
Exactly.
But there's always a catch, right?
Right. Well,
remember-
theanomycin, while powerful, was unstable. Think of it as a superhero with a weakness.
Okay.
It broke down very quickly in liquid form, and it was difficult to work with.
Oh, so like a superhero who's allergic to their own cape.
Exactly. But scientists, being the brilliant minds they are,
Yeah.
they weren't deterred. They saw the potential in theanomycin and spent years researching and modifying it. And finally, in 1985, they achieved a breakthrough, the first stable carbapenem.
Imipenem.
But they didn't stop there.
Oh.
They cleverly combined it with cylistatin.
Okay, so we have Imipenem, our hero, and cylistatin's the trusty sidekick.
Right.
What does cylistatin do?
Cylistatin plays a crucial role.
Okay.
See, our kidneys have this enzyme, DHP1,
Okay.
and it loves to break down imipenem.
Oh, no.
So cylistatin steps in and blocks this enzyme,
Okay.
prevents imipenem from being destroyed prematurely.
So it's like giving Imipenem a protective shield.
Precisely. This means that imipenem can circulate in the body longer, reach higher concentrations, giving it more time to knock out those bacterial bad guys.
Nice.
And as an added bonus, it reduces the risk of kidney damage from byproducts.
Win-win.
Talk about a win-win.
That's fantastic.
Yeah.
So they basically gave our superhero a special suit of armor.
Right.
Now, I'm kind of curious, what do these carbapenems actually look like?
At their core, carbapenems have a very distinct structure.
Okay.
Imagine a 5-membered carbon ring attached to a beta-lactam ring.
Okay.
This unique configuration is their defining feature.
I'm sensing a connection here.
Oh,
Carbapenems, carbon rings.
you're catching on quick. The name carbapenem actually comes from the abundance of carbon atoms in its structure.
That makes sense. It's like their chemical fingerprint.
Precisely.
Okay, so they have this unique ring structure. But is that all? Like, can scientists tweak it
Yeah.
to create different carbapenems with different powers?
You're exactly right. By making small changes to specific points on the molecule, particularly at positions C3 and C4,
Okay.
scientists can fine-tune a carbapenem's properties.
Oh, cool.
These modifications can affect its stability, how well it fights specific bacteria, and even reduce potential side effects.
So they're customizing each carbapenem for specific missions.
Precisely. They can create a carbapenem that's particularly good at fighting a certain type of bacteria.
Wow.
Or one that's less likely to cause certain side effects. It's like having a toolbox.
Okay.
It's full of specialized tools for different jobs.
That's pretty incredible. It's like they're designing these carbapenems to be super effective against specific enemies.
Yeah.
So we've covered their origin story. We've covered their unique structure.
Right.
Now I'm really curious about their superpowers.
Okay.
How do these carbapenems actually fight bacteria?
Carbapenems, like other beta-lactam antibiotics,
Okay.
work by interfering with how bacteria build their cell walls.
Oh.
Imagine bacteria as tiny walled cities.
Right.
To survive, they need to constantly repair and build their walls, which are made of peptidoglycan.
Okay, so we've got our tiny bacteria cities diligently building their walls.
Yes.
How do carbapenems disrupt this?
Think of carbapenems as sneaky saboteurs.
Okay.
Who infiltrate the city and sabotage the construction process.
Right.
They target the crucial construction workers responsible for building and maintaining the wall.
Okay.
Enzymes called penicillin-binding proteins, or PBPs for short.
Penicillin-binding proteins.
Yes.
That's where that beta-lactam part comes in.
Right.
They bind to these proteins and mess things up.
Exactly. Carbapenems, like other beta-lactams, bind to and inactivate PBPs. Without these essential workers, the bacteria city wall weakens and eventually crumbles.
So it basically self-destructs.
Pretty much, leading to the bacteria's destruction.
Wow. It's like they're tiny ninjas sneaking in and disabling their defenses.
I like that analogy. And remember how we talked about tweaking the carbapenem structure?
Yes.
Well, the specific PBPs a carbapenem targets can influence its fighting style or spectrum of activity.
Oh.
Some carbapenems are better at fighting certain types of bacteria than others.
So it's like some ninjas are better at stealth while others are masters of hand-to-hand combat.
Exactly.
I got it.
Good.
But once a carbapenem is in the body, how does it actually get to the site of infection?
Yeah.
Like, does it have a GPS or something?
Not quite a GPS, but it does have a very impressive distribution system. We call this pharmacokinetics, the study of how drugs move through the body.
Pharmacokinetics.
Yes.
Sounds a little intimidating, but I'm ready.
It's simpler than it sounds. Think of it this way. When you give a carbapenem intravenously, it hops on the bloodstream expressway.
Starts traveling throughout the body.
So the bloodstream is like a highway system.
Exactly.
Right.
And each carbapenem has its own travel itinerary, so to speak.
Okay.
For instance, Imipenem celestatin
Right, our dynamic duo.
has a half-life of about an hour in people with healthy kidneys.
Okay.
But for those with kidney problems, it can hang around for about 5 hours.
Oh, wow.
And then another Carbapenem Meropenem
Okay.
has a half-life of roughly an hour in folks with normal kidneys, but can stick around for a whopping 10 hours in those with kidney issues.
Wow, that's quite a difference.
It is.
So it seems like Meropenem likes to take the scenic route, while Imipenem celestatin is more of a quick in-and-out mission.
That's a great way to put it.
But is there more to the story than just half-life?
Yes, there is. We also need to consider Cmax and VED.
Cmax and VED.
Yes, Cmax is like the peak of the carbapenem's journey.
Okay.
It's the maximum concentration that reaches the bloodstream.
Okay, I think I'm following so far.
Good.
Yep.
What about VED, or volume of distribution?
Tells us how widely a carbapenem spreads throughout the body.
Oh, okay.
Imagine it like this. Some carbapenems are like explorers, venturing deep into various tissues, while others prefer to stay closer to the main roads.
So some carbapenems are expert hikers, while others prefer a comfortable bus tour.
I like that.
My brain feels like it's on a roller coaster with all this pharmacokinetic talk.
I bet.
Can you give me a real-world example of how this all works?
Sure. Imagine a patient with a serious lung infection.
Okay.
Carbapenems are known for their ability to reach high concentrations in various tissues, including the lungs.
Okay.
For example, Meropenem can achieve levels in the lungs that are about 25% of its concentration in the blood.
So even though it's not as high as in the blood, it's still enough to fight those bacteria hiding out in the lungs.
Exactly. And it's not just the lungs.
Okay.
Carbapenems can reach therapeutic levels in other crucial areas like peritoneal fluid, urine, and even bone.
So they really are antibiotic all-stars,
They are.
capable of tackling infections all over the body. Yeah. But here's a question. Once they reach their destination, what determines how effectively they actually kill the bacteria? Is it simply about reaching a certain concentration?
That's a great question, and it leads us to another important concept. Pharmacodynamics.
Pharmacodynamics.
Yes, this is all about how a drug interacts with bacteria at the infection site.
Okay, lay it on me.
When it comes to carbapenems, it's not just about reaching a certain concentration.
Okay.
It's also about how long the drug concentration stays above a critical level.
Okay.
We call this level the MIC, or the minimum inhibitory concentration.
Minimum inhibitory concentration. So the minimum amount of drug needed to stop those bacteria from growing.
You got it. And here's a key point. Carbapenems are most effective when their concentration stays above the MIC for a specific period.
Okay.
In fact, they need a shorter time above the MIC compared to other beta-lactam antibiotics like penicillins and cephalosporins.
So carbapenems are like the express train of antibiotics.
I like
They get the job done fast. But I'm guessing they're not invincible, right?
Right.
Bacteria are crafty, And I bet they've found ways to resist these antibiotic attacks.
Unfortunately, you're right.
Oh, no.
While carbapenems are incredibly powerful, the rise of antibiotic resistance is a serious concern.
Okay.
It's like those bacterial cities have learned how to build walls that our carbapenem ninjas can't penetrate.
So even our antibiotic superheroes have their weaknesses.
Sadly, yes.
This sounds like a cliffhanger.
It is. We'll dive into those bacterial defense strategies,
Okay.
how scientists are fighting back in part 2.
Stay tuned.
Stay tuned. Welcome back. Ready to explore how those sneaky bacteria resist even our most powerful antibiotic ninjas.
Absolutely. Last time we left off with that cliffhanger.
Right.
About how some bacteria have actually developed these defenses against carbapenems.
They have.
Like they've upgraded their city walls to fortresses.
Yes, they have.
So tell me more about that.
Well, bacteria, they're incredibly adaptable, and they've evolved all these tricks to survive.
Yeah.
Even in the presence of carbapenems.
Wow.
One of their most potent weapons is actually producing these enzymes called carbapenems.
Carbapenems. Those sound like serious adversaries.
They are.
What do they do?
These enzymes are like tiny Pac-Man characters that gobble up carbapenem molecules,
Oh, no.
rendering them ineffective.
So they've built a carbapenem-eating army.
Pretty much. Some bacteria, like certain types of Enterobacterales and Acinetobacter, are particularly good at producing these carbapenems.
Okay, those are some of the heavy hitters in the bacterial world.
They are.
What about Pseudomonas?
Yeah.
Those crafty bacteria we talked about earlier. Do they have any unique defenses?
Oh, Pseudomonas have their own cunning tactics.
Oh, yeah.
They've become masters of disguise and fortification.
Right.
Imagine this. Some Pseudomonas have actually altered their outer membranes, making it incredibly difficult for carbapenems to even enter the cell.
So they've basically gone into lockdown mode.
Precisely. And to make matters even trickier, some Pseudomonas have also developed these tiny pumps that actively expel carbapenem molecules that manage to sneak inside.
Wow, so they're like kicking them out.
They are. It's like having bouncers at the city gates tossing out any unwanted visitors.
Bacteria are like master strategists when it comes to survival.
I know, it's incredible.
I'm amazed. Well, what about those penicillin-binding proteins?
Yeah.
The PBPs that carbapenems target.
Yes.
Can those change too?
Absolutely. Bacteria can develop mutations in their PBP genes.
Oh, wow.
Leading to altered PBPs that carbapenems can't bind to effectively.
So they've disguised themselves.
Exactly.
Sneaky, sneaky.
It's a constant battle.
So we've got bacteria producing these carbapenemases.
Right?
Reinforcing their cell walls.
Yeah.
Pumping out carbapenems. And even disguising their PBPs. It's like a full-blown antibiotic resistance war.
It can feel that way sometimes.
Yeah.
Especially when bacteria develop multiple resistance mechanisms.
Oh, no.
This is called cross-resistance. And it means that a bacterium resistant to one carbapenem might also be resistant to others.
So they become like super resistant villains.
Essentially.
How do we even fight back against such formidable foes?
Well, scientists are constantly working on new strategies.
Okay, good.
And one promising approach is actually to combine carbapenems with beta-lactamase inhibitors.
Beta-lactamase inhibitors?
Yes. Remember stalostatin?
Oh, yeah.
The trusty sidekick that protects Imipenem?
Right.
These beta-lactamase inhibitors work similarly,
Okay.
but on a broader scale.
So like sending in reinforcements.
Exactly. These inhibitors shield carbapenems from those carbapenes Pac-Man characters,
Right.
allowing them to reach their target and do their job.
Okay.
There are a couple of dynamic duos that have shown great promise.
Okay, tell me more.
One is Meropenem, combined with Vaborbactam,
Go.
and it's marketed as Vabomere.
Vabomere, that sounds like a superhero team-up.
It is, and this combo is particularly effective against those carbapenem-resistant Enterobacterales, or CRE, that produce a specific type of carbapenemes called KPC.
KPC, is that like a supervillain code name?
You could say that KPC stands for Klebsiella pneumonia carbapenemes.
Oh, okay.
And it's one of the most worrisome carbapenemeses out there.
Got it.
So Vabomere is like a specialized task force
Okay.
sent in to take down those KPC-producing bacteria.
All right, so Vabomere is our CRE fighting specialist.
Yes.
Are there any other dynamic duos in the carbapenem world?
There is another powerful team. Imipenem cilastatin combined with Relebactam.
Okay.
And this one is marketed as Ricarbrio.
Carbrio. Another name that sounds like it belongs in a comic book.
I know.
What's so special about this duo?
Ricarbir has a broader range of activity.
Okay.
It's effective against CRE that produce not only KPCs,
Okay.
but also some OXA-type carbapenems.
Wow.
And get this, it's also effective against carbapenem-resistant Pseudomonas aeruginosa.
So Ricarbio is like the ultimate weapon.
It's pretty close.
Are these dynamic duos used often?
Not exactly. They're considered last-line agents, meaning they're typically used when other antibiotics have failed.
Got it.
So they're like our secret weapons saved for the most challenging battles.
That makes sense.
Yeah.
We need to save our heavy hitters for the toughest opponents.
Right.
But even with these powerful weapons,
Yes.
it's clear that preventing antibiotic resistance is still crucial.
Absolutely. Antibiotic stewardship.
Okay.
Using antibiotics wisely and only when necessary is essential
Right.
to preserve the effectiveness of these life-saving drugs.
It's like we need to train our carbapenem ninjas responsibly,
Exactly.
not sending them into every minor skirmish.
Right.
We don't want to wear out our superheroes.
We don't.
Speaking of which,
Yeah.
I'm kind of curious about the potential side effects of carbapenems.
Okay.
No superhero is without their kryptonite, right?
Right. What should we watch out for?
Yeah.
You're right. Every medication comes with potential risks.
Mm-hmm.
While carbapenems are generally well tolerated,
Okay.
we do need to be aware of the possible side effects. One of the most concerning is seizures.
Seizures.
Yes, particularly with imipenem cilastatin.
That sounds serious.
It can be.
Why is imipenem cilastatin more prone to causing seizures?
The exact mechanism is still not fully understood,
Right.
but it's thought to be related to imipenem's ability to cross the blood-brain barrier
Mm-hmm.
and potentially interfere with neurotransmitters in the brain.
Okay.
It's like sometimes our carbapenem ninja gets a little too adventurous
Oh.
and wanders into areas where it shouldn't.
Got it. Okay, so seizures are a big one, especially with imipenem cilastatin.
Right.
What other side effects should we be aware of?
Like most antibiotics, carbapenems can cause gastrointestinal issues,
Okay.
like nausea, vomiting, and diarrhea.
Oh.
And unfortunately, they can also increase the risk of developing C. difficile infection.
C. difficile.
Yes, a nasty bacterial infection that can cause severe diarrhea.
Yeah, that is definitely not something you want to mess with.
It's not.
So GI issues are on the watch list.
Yes.
Anything else?
We also need to keep an eye on liver and kidney function.
Okay.
Carbapenems can cause elevations in liver enzymes.
Okay.
Though liver failure is rare,
Mm.
they can also lead to acute kidney injury, especially in people who already have kidney problems.
So monitoring liver and kidney function in patients on carbapenems is key.
It is.
Makes sense.
Yes.
Anything else we should be aware of?
Yes. We also need to be mindful of potential allergic reactions,
Okay.
which can range from mild skin rashes
Okay.
to severe anaphylaxis.
Wow.
And they can sometimes cause blood-related issues like a decrease in white blood cells, red blood cells, or platelets.
Wow, that's quite a list.
It is.
Is there a way to remember all of these potential side effects?
Actually, there is.
Oh, good.
Think CHINS.
CHINS.
C is for CNS effects like seizures.
Okay.
H is for hypersensitivity reactions like rashes and anaphylaxis.
Mm-hmm.
I is for imipenem, the carbapenem with the highest seizure risk.
What?
N is for nephrotoxicity or kidney damage.
Right.
And S is for superinfections like C. difficile.
CHINS. Love it. That's going to be super helpful for remembering those potential side effects.
Good. I'm glad.
Okay, so we've covered the common ones.
Yes.
Are there any drug interactions we need to watch out for?
There's one very important interaction to keep in mind.
Okay.
Valproic acid.
Valproic acid. That's an anti-seizure medication,
You
right?
got it. And here's the issue. Carbapenems can significantly reduce valproic acid levels in the blood,
Uh-oh.
potentially leading to a loss of seizure control.
That sounds like a dangerous situation.
It can be. What do we do if a patient is taking valproic acid and needs a carbapenem?
Wow.
It's a delicate balancing act.
Yeah.
Sometimes we can try increasing the valproic acid dose,
Okay.
but that doesn't always work.
Right?
In many cases, we have to consider alternative antibiotics or
Yeah.
anticonvulsants.
Okay, so careful medication management is crucial in those cases.
It is.
Are there any other drug interactions to be aware of?
Yes. One more to mention. Probenecid.
Probenecid. That rings a bell. Isn't that a medication for gout?
Exactly. And it can interfere with how carbapenems are eliminated from the body, potentially increasing their concentration and the risk of side effects.
Okay, another interaction to keep in mind. So we've covered a lot of ground on carbapenems.
We have.
Their history, how they work their strengths, their weaknesses, and even their potential side effects and interactions.
Yes.
Before we move on to the final part of our carbapenem deep dive,
Okay.
I have a quick question for you, a little knowledge check to see how much you've absorbed so far.
Okay.
Ready for a challenge?
Bring it on.
All right, here it is. Which of the following carbapenems has the longest half-life in patients with normal kidney function?
Okay.
A. Imipenem, B. Meropenem C, Doripenem, or D. Ertapenem?
Okay.
Think carefully about those pharmacokinetic parameters we discussed.
All right.
I'll give you a few seconds to ponder.
Take your time, everyone. It's not a race.
Yeah.
We're all about learning here.
Okay, time's up. What's the answer?
The answer is D. Ertapenem.
And can you remind us why?
Of course, Ertapenem has a half-life of about 4 hours in people with normal kidney function. That's significantly longer than the other options.
Got it.
Imipenem and Meropenem both have half-lives around 1 hour, and Doripenem falls somewhere in between.
Excellent. Thanks for the explanation. Now, before we jump into the final part of our carbapenem adventure,
Okay.
is there anything else you want to share about ertapenem?
Sure.
It seems to have a unique advantage with its longer half-life.
It does. Ertapenem has a special structural feature that makes it stand out from the crowd.
Okay.
It allows for once-daily dosing.
Once daily dosing.
Yes.
That sounds incredibly convenient.
It is. What's the secret behind this unique feature? Ertapenem has this interesting 1-methyl group
Okay.
and a meta-substituted benzoic acid group.
Okay.
These features give it a longer half-life and increase its protein binding.
Okay.
This means it can stay in the body longer and requires less frequent dosing.
But I'm guessing there's a trade-off, right?
There is.
Does this unique structure affect its activity against certain bacteria?
You're sharp. You're absolutely right. Because of its anionic character,
Okay.
Ertapenem has difficulty penetrating the outer membrane of Pseudomonas, so it's not effective against those particular bacteria.
So it's like Ertapenem traded some of its Pseudomonas fighting power for the convenience of once daily dosing.
Exactly. It's a classic example of choosing the right tool for the job.
Speaking of the right tool, are you ready to explore the carbapenem arsenal in more detail?
I am.
Let's head into the final part of our deep dive
Okay.
and see which bacteria end up on the carbapenem hit list. Okay, we're back for the final round of our carbapenem deep dive. We've covered their origin story, their molecular structure, how they take down bacteria, how they travel through the body,
Yes.
and even some of their limitations and side effects. Now, I'm ready for the big reveal, which bacteria make it onto the carbapenem hit list.
All right.
It's like we're choosing our targets for a mission.
Let's imagine a battlefield where all these different bacterial enemies are lined up.
Okay.
And carbapenems are our elite strike team.
I like it.
Remember those spectrum of activity charts we mentioned earlier?
Yes.
Those are like our battle maps,
Okay.
showing us which bacteria are most vulnerable to carbapenem attacks.
All right, I'm visualizing it. So which bacteria are in the carbapenem crosshairs?
Carbapenems are actually renowned for their broad spectrum coverage,
Okay.
meaning they can take down a wide range of bacterial bad guys. They're especially effective against many gram-negative bacteria,
Okay.
including some of the heavy hitters like E. coli,
Right.
Klebsiella species, and even some Enterobacter species.
Wow, those are some of the big names in the bacterial world.
They are?
What about gram-positive bacteria? Are they on the target list too?
They are, but to a lesser extent.
Right.
Carbapenems do have some activity against gram-positive bacteria, like Streptococcus pneumonia and some Staphylococcus species.
Good.
But they're not always the first-line choice for those infections.
So it's like they have a primary target, gram-negative bacteria, and a secondary target, gram-positive bacteria.
Exactly.
Got it.
And here's another crucial point.
Okay.
Carbapenems are valuable weapons against bacteria that produce those pesky beta-lactamases.
Right. Those are the enzymes that try to dismantle beta-lactam antibiotics.
Yes.
Like sneaky saboteurs.
Right.
Rendering them ineffective. But carbapenems are resistant to those attacks. Right?
Exactly. They're like those elite soldiers that are trained to disarm those saboteurs before they can do any damage.
Okay.
But remember, bacteria are constantly evolving. And while carbapenems are effective against many beta-lactamase producers, we're now facing a new challenge. Carbapenem-resistant organisms, or CROs.
It's like those villains in the movies who always seem to come back stronger.
I know.
Are those carbapenem-resistant Enterobacterales, those CREs at the top of the most wanted list?
Yeah, they are a major threat because they've developed resistance to even our most potent carbapenems.
It sounds like we're in a constant arms race with these bacteria.
In a way, we are.
Yeah.
That's why judicious use of carbapenems is so crucial.
Right.
Overusing them can actually accelerate the development of resistance, making these infections even more challenging to treat.
It's like we need to deploy our carbapenem strike team strategically.
Yes.
Not sending them into every minor battle.
Yeah.
We need to preserve their effectiveness for when we really need them.
Exactly.
Well, this deep dive into carbapenems has been quite a journey.
It has.
You know, we've explored their discovery, their structure, their mechanisms of action, their spectrum of activity, the challenges of resistance, potential side effects, drug interactions, and even some helpful mnemonics along the way.
We did.
I feel like I've just completed a crash course in carbapenology.
I'm glad to hear it.
I never thought learning about antibiotics could be so captivating.
It's fascinating stuff.
It's like we've uncovered the secret world of these microscopic warriors.
I agree. I'm glad you enjoyed the journey. And remember, learning about infectious diseases is an ongoing adventure. There's always something new to discover. And it's through continuous exploration that we can stay ahead of those ever-evolving bacterial adversaries.
Absolutely. And as we conclude our carbapenem exploration, I want to leave our listeners with a sense of empowerment.
Yeah.
You know, we've delved into the complexities of these powerful antibiotics.
Yeah.
And now you have the knowledge to understand how they work when they're used and the importance of using them responsibly.
I hope so.
Knowledge is power. And by understanding the intricacies of antibiotic therapy,
absolutely,
you can be advocates for your own health and contribute to the fight against antibiotic resistance.
I completely agree.
Well, thank you for joining us on this carbapenem deep dive. Until next time, stay curious, stay informed,
and stay well.
And stay well.